The way this robot moves is raising eyebrows. ENGINEAI says the robot, named the SE01, is about to redefine humanoid robotics. The Chinese robotics startup is positioning the AI robot as yet another competitor for the Tesla Optimus. They call it the coolest robot on the planet, and they're aiming to manufacture 1,000 of them per year by 2025. According to ENGINEAI, the humanoid robot uses advanced end-to-end neural networks to master smooth, human-like walking. With training, it's overcome common challenges like jerky steps and bent knees. It combines reinforcement and imitation learning with a custom joint system to make smooth, flexible, human-like movements. The humanoid is equipped with dual processors from NVIDIA and Intel. Its 3 stereo cameras form a sophisticated visual network for navigating and interacting with complex environments, which ENGINEAI says suits it for research and industrial applications. The robot's frame is aerospace-grade aluminum. With its unique motion control system, the robot lacks traditional sensors. Each leg has 3 hip joints, 1 knee joint, and 2 ankle joints for flexible movement. ENGIN says the robot's soft, curved design is for safety around humans. Its expandable chest design allows for easy swapping of head and hand modules with a quick release system. Its battery runs for about 2 hours with a quick change battery system. Its walking speed is 2 meters per second, or just under 4.5 miles per hour. At that pace, the SE01 is between Digit by Agility Robotics and the Tesla bot, whose reported walking speeds are 1.5 and 2.2 meters per second, respectively. In a press release, ENGINEAI leader Zhao Tongyang said he views the robot as a fusion of technology and art. He said the company is developing a full product line with plans to introduce new models for industrial and household use cases. Earlier this year, ENGINEAI unveiled its SE01, calling it an affordable, professional-grade, open-source humanoid starting at $5,300. That model is intended for education and research. ENGINEAI was founded in October 2023. According to its website, the Shenzhen-based robotics firm's team includes experts from UC Berkeley, Tsinghua, and Purdue. The company says it does all its research and development in-house. Their ultimate goal is to mainstream humanoid robots in industry and at home. They're entering the fray as a growing array of firms emerge as the Chinese government and investors pour funding into the humanoid robotics market. They're dead set on mass-producing humanoids in 2025 and cornering the market globally by 2027. ENGIN is one of several firms focusing on realistic human-like movements. Among them is Ptics, which just released this footage of its humanoid known for its smooth movements, Adam, at IRS 2024 in Abu Dhabi. Adam is noted for its human-like locomotion achieved through whole-body imitation learning. The company says Adam is the first high bionic robot, meaning it closely imitates the biological structure and movements of a real human. Adam's pelvis is designed to move like a person's using joints and actuators that mimic natural motion. This includes heel-to-toe walking and running. Researchers detailed their findings developing Adam in a recent paper. It has 25 quasi-direct drive actuators that provide force control and high sensitivity. The motor system combines the benefits of direct drive and geared motors. It's equipped with a real-time communication network, a motion control computer with a 12th generation i7 processor, and a programmable switch with network management capabilities. D&D describes itself as a full-stack developer and manufacturer of humanoid robots. The company uses deep reinforcement learning for sophisticated AI-driven motion control. On its website, the company says it's built an intelligent manufacturing center, enabling full in-house development, production, and sales of robot components like motors and joints to build humanoids. Like ENGINEAI, PND emphasizes its robot's modular design so it can be easily serviced and upgraded as technology advances. Meanwhile, Forai just shared this cheeky footage of its advanced AI robot, the GR2, in the beginning of its bodybuilding journey. In the video, the humanoid robot goes nuts with a pair of adjustable dumbbells that presumably weigh 6.5 kilos or 14.3 pounds each. For a human, curling that much in each hand is relatively light, especially for regular weight trainers. For a humanoid robot, though, it's notable as it requires highly advanced strength and dexterity. While a robot weight training might seem like a farce, it has valuable applications. For example, the GR2 could assist patients performing strength training exercises for physical rehab, which is a particularly strong domain for Forai. Founded in 2015, Shanghai-based Forai initially focused on rehab technology. As Forai gained a reputation for pushing boundaries, the company ventured into humanoid robotics. When Forai introduced its first-generation humanoid, the GR1, in 2022, they leaned heavily into patient care. Forai's rehab division offers Rehab Hub, a platform that integrates devices for walking, standing, and balance improvement, along with Metamodus Galileo, a lower body exoskeleton system to help patients regain strength and mobility. Forai introduced its second-generation humanoid earlier in October, emphasizing its high torque rating and 53 degrees of freedom. Its 380 Newton-meters of torque is enough to lift patients into wheelchairs, move furniture, and operate industrial tools. In a video posted on Forai's website, the robot is seen performing tasks at an SAICGM facility in China. The GR1 had 300 Newton-meters for torque, which is sufficient for lifting its own weight, but offered much less power than the GR2. Forai says the GR2 has 12 degrees of freedom in its hand. That's the same as NASA's Robonaut R2, which is designed for precise tasks in space. Forai's advanced actuation system provides precise control of the robot. Each joint in the GR2 is powered by a flexible series actuator unit specifically tuned to meet its unique torque demands. According to Forai, the system's dual encoder system doubles control accuracy so the robot can perform high-precision tasks even in challenging environments. Compared to the GR1, Forai's latest robot actually has one less degree of freedom. Humanoid robot designs strike a balance between complexity and practicality. With the reduction, the Gen 2 robot may have gained enhancements in strength, stability, or battery efficiency. Leading Chinese robotics company Unitree just released this footage of its G1AI robot jumping 1.4 meters or just over 4.5 feet. It makes the robot the likely record holder for the longest standing long jump achieved by a humanoid its size. That's about the length of a standard park bench or dining table. The feat is especially impressive considering the G1's stature of 1.3 meters or 4 feet 3 inches, which is comparable to an average 6 or 7-year-old child. The jumping capabilities put the G1 in the same league as Cassie by Agility Robotics, a bipedal robot that lacks a humanoid upper body. For full-sized humanoids, Atlas by Boston Dynamics is likely capable of outperforming the G1 in a long jump, though no official record is available for comparison. Atlas's advanced agility and powerful leg motors suggest it could jump farther, based on its demonstrated abilities like backflips and parkour. Calling it a world first, Booster Robotics shared this footage of its T1 humanoid robot besting a quadrupedal robot in a soccer match. The video is from IROS 2024 in Abu Dhabi, where the Beijing-based startup showcased its Booster T1 robot that's now available for purchase. On the X social media platform, Booster Robotics said it's an event that will go down in history. The game, which appears to be unofficial, pit 3 of the pint-sized T1s against 3 Unitree Go-2 quadrupeds. Regardless, the feat is notable because humanoids typically struggle with stability compared to quadrupedal robots. The Booster T1, which stands 1.2 meters and weighs 30 kilos, has gained significant attention for its advanced motion control for flexible movements. Bipedal and four-legged robots are judged separately in robot games due to their different mechanical structures and movement challenges. Humanoids are more prone to falling and require advanced motion control to balance on 2 legs. Quadrupeds benefit from their inherently superior stability, which allows them to focus more on manipulating objects like soccer balls without stumbling. Compared to humans, neither is a threat on the soccer field, at least not yet. RoboCup was established in 1997 with the ultimate long-term goal of creating a team of fully autonomous humanoid robots that can defeat the Human World Cup champions in a real soccer match by the year 2050. Ultimately, humanoid robots likely have the edge over quadrupeds on the field as technology replicating human-like complex motor control, balance, and strategic decision-making advances. Robots like MIT's Dribblebot can traverse rough surfaces while controlling the ball, but they struggle with the dynamic coordination and strategy needed to formidably challenge real athletes. Though ambitious, rapid advances in AI and robotics could make humanoid robots better than the world's top soccer players sooner than expected.